Now let's provide the loadings. I will just first of all switch off the show mesh option. Yeah, so this is my object. Let me look into the Z and let me zoom in and place to proper position. Okay, so we'll go to the environment. We'll go select a edge. We'll select this edge, and on the environmental context ribbon I will click on convection. So this side there is a hot gas flowing. Here the environment temperature is 20. So convection, film coefficient is 30 watt per meter square degrees Celsius. It's in mm here. Let me change the unit to meters. So it's 30 watt per meter square degree Celsius, and temperature of gas is 800 Celsius, right? On this extreme right side we have a temperature, fixed temperature of 20 degrees Celsius, right? So these are the two properties. On left hand side we have convection, on right hand side we have fixed temperature of 20 degrees Celsius. Let's solve this. So analysis is solved. Let's see how temperature distribution occurs. We'll go to the solution by going into context menu, or just right click and say insert thermal temperature. So this is the temperature distribution. Here on the right hand side, as we have provided a temperature of fixed temperature of 20 degrees Celsius, definitely the right hand side is the essential boundary condition and it has to be at 20 degrees Celsius. So that's first sanity check or cross check whether it's correct or not. Here we are getting a temperature of 319 degrees Celsius. So that's we are going to verify using hand calculation approach, and we'll see whether the answers matches with our theoretical understanding or not. So we also will find out here total heat flux to understand what is a heat transfer. It's 14406 watt per meter square. We'll just drag and drop this to boundary condition to the solution. So I will get the reaction, what is the heat transfer rate from here and here. So heat transfer is 14406 watt here, and here minus 14406. Let's find out, you can find out the total heat flux or temperature, let's see in a vector view. So we'll go to the total heat flux and we'll switch on this vector view, right? So heat transfer flows from high temperature to low temperature, right? So that's what being captured here. Also you can make this lines proportional, uniform. You can increase the sizes of arrows, right? You can make it solid, whichever way you like. So this way it's a good practice to see how the heat transfer flow is taking place. So now next we are going to cross check with the hand calculation the reactions and the temperature what we get from hand calculation in next session.